Me tomorrow.
Alright, so this is chapter 7. We're going to do lesson 1 and 7 in the same note taker. So this is actually lesson 1 and lesson 7. Alright, so this one is talking about ratios. Ratio. A ratio is a comparison of two quantities using division. Like your test grade, right? You're comparing it out of 100 to get a percent. Does it always have to be out of 100? No, doesn't always. The ratio of quantities A to B can be written in 3 different ways. This is way number 1. You could say A to B. Or you could say A colon B. That's the second way. And the third way is A over B, or A divided by B. As long as B is not equal to 0. If it's equal to 0, then it means it is undefined. So you can't write anything over 0. Ratios have to be expressed in simplest form. Simplest form. You can also compare more than 2 ratios. So if you have 3 or more, it's considered to be an extended ratio. Extended ratio. How many of you remember those word problems? If so-and-so had 3 marbles and 5 marbles and 10 marbles, what's the, Yeah, in 3rd grade. Okay, so this is like comparing those marbles. Let's say you have 3 to 4 to 5. Okay, we're comparing 3 different things. That means the ratio of the first 2 terms is 3 to 4. The last 2 is 4 to 5, and the ratio of the first and last is 3 to 5. So first 2, 3 to 4, last 2, 4 to 5. If you're comparing all 3. And then the first to the last is 3 to 5. The important thing about this is if you're setting up these proportions and these quantities, if you're talking about students, students always have to be on top. If you're talking about chairs, chairs always have to be on bottom. Okay, you always have to keep whatever it's talking about top and bottom. So in Logan's High School, there are 190 teachers. So what's the first topic we're talking about? Teachers. For how many students? So what's the ratio I'm finding? Student to teacher. Okay, so if I'm going to set up this ratio, I need to keep students, because student comes first, student to teacher. Student to teacher. So student and then teacher goes on bottom. Student to teacher. So how many students are there? Good. 2,650 students and 190 teachers. So when you simplify that, when you get it in simplest form, how many students are there for every one teacher?
When you just divide it?
Yeah, just divide this right here. Plug this in your calculator.
So, 14?
What did you get before? 13.95. Can we have a 9/5 or a 95,000 hundredth of a student? Huh? But it's still a whole person. Still a whole person. Okay, so let's simplify. Let's round this. So there are approximately 14 students per teacher. All right, how many baseball players we have in here? All right, this is all for you, AJ. Batting average. Baseball players' batting average is the ratio.
You got softball players. You got him.
Softball players, yep. Ratio is the number of base hits. So here's our ratio. Number of base hits to the number of at-bats. So when we're setting up this ratio, we have to put what on top? Base hits. Base hits goes on top. And at-bats go on bottom. That's how you find the average. How many times do they actually get a base hit versus how many times were they at-bat? So, Minnesota Twins player had the highest batting average in the MLB in 3006. I think it's just a typo. Okay? If he had 521 at-bats and 181, what was his batting average? Be very careful because they have this order flipped. They gave you official at-bats first, which goes on bottom. So 521 at-bats, 181 hits. Okay, but is 340, like how do I write that? Uh-huh. Is that good or bad?
That's good.
That's good? Well, he had the highest batting average, right?
You get on base 3 out of 10 times.
Okay, yeah.
That ain't good.
That is good. You feel Hall of Fame.
I get on base every time.
I swear you.
So, wherever, is the denominator in this case 1? Right? Because we're talking about per one time. For every time he goes up, he's likely to get on base, like AJ said, every 3 out of 10. This is called a unit rate. A unit rate is whenever the denominator is 1. Go stand up in the back. It's okay. Go stand up. All right. So we're not always going to relay this back to baseball. Somehow it always goes back to what? We're in geometry. What do we always talk about? What kind of shape in particular? Triangles. Triangles. So the ratio of the measure of angles in a triangle. Okay, here's your triangle. The ratio of the measures of angles in a triangle is 3 to 4 to 5. So I need to find what the actual angles are. How many degrees is a whole triangle? 180. If you've learned anything, I hope you've learned that. Okay, so one angle could be 3x, one could be 4x, and one could be 5x. Because they're in a ratio of 3 to 4 to 5. 3 to 4 to 5. Don't all these x's cancel out so that it is 3, 4, 5? Good. Okay, so let's take 3x plus 4x plus 5x, because those are all the angles, set it equal to what? 180. 3x plus 4x plus 5x equals 180. 3 plus 4 is? 7. 7 plus 5?
12.
So 12x is equal to 180. So x is equal to? Close.
16.
Close. In the middle.
15.
Yeah. Okay. Me 5. Okay, but I'm not.
Me 3. She said me 5. Me 4. I mean, both of here said me 4.
Yeah, y'all didn't hear that ghost? Okay, so I wasn't finding x though. I wasn't finding x. I want to find the actual measure. So if I knew that this was 3x and 4x and 5x, what you think I'm going to plug in? 3 times 15. 4 times 15. 5 times 15. And that will give you all 3 of your angle measures. So 3 times 15 is?
45.
Okay. 60. Alright. If I wanted to check, all three of these need to add up to be what? Okay, if you just want to double check yourself, if you added all three of these up, they would equal 180. Okay? Alright. Number 4. We're still talking about triangles. In a triangle, the ratio of the measure of sides. Sides. So here's your triangle. The ratio of the sides is 2 to 2 to 3. What kind of triangle is it? Isosceles. And the perimeter is 392. Perimeter is 392. How do I find the perimeter of a triangle? Add all the sides together. Add all the sides together. So this one would be 2x, 2x, and 3x. What if all of these sides have to equal? Sides. The perimeter. 392. Talking about the perimeter. So in order to find the length of the sides, I first need to find x. So 2x plus 2x plus 3x equal 392, or 7. 7x equals 392. Okay, I want you to solve for x and then tell me the lengths of the side. Because it gave me the ratio 2 to 3. That's how I found out these numbers. 2 to 2 to 3.
I've seen it 392, but I see it.
Okay. So I got that x is equal to 56. And what am I talking about? Tell me what I'm talking about. What's the unit? Inches. So how long are each of these sides? Okay, so 56 times 2 tells me that I have two sides that are 112 inches. 112, 112. And then my third side, 3 times 56 is 168 inches.
Are you going to take points off if we don't put it into the
Yes. All right, halfway done.
halfway done?
Just trying to think positive. To the back.
Mason, please.
All right, an equation stating that two ratios are equivalent. An equation saying that two are equivalent, they are equal, is called a proportion. 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 A as to B as C is to D. That's how it's read. A over B is equal to C over D. How many of y'all remember cross products?
I do.
Okay, we're going to practice. Look at example 5. If you want to solve for x, we cross multiply. If you want to solve for x, you cross, did I just say the wrong terminology? Do y'all know how to cross multiply? So you cross, what is x times negative 6? Negative 6x. 4 times 11 is 44. To solve for x, you divide by negative 6. So x is equal to, I think you're going to get a fraction. Negative 22 over 3.
Yeah, it's 7.
It's probably the same thing. I just left mine as a fraction. Okay? Now, if you're cross multiplying and you have more than one term, I recommend you putting parentheses around it. So if we're cross multiplying on number 6, when you cross multiply, you have to distribute that 4. So when you set it up, it should look like this. 4 times 2x plus 5 equals 6 times 7. So now you have to distribute. 4 times 2 is 8x. 4 times 5, 20, equals 42. I want you to finish out 6 and 7. Did y'all get x is 2.75 for number 6? Okay. Are y'all trying 7?
I'm sorry.
Yeah? Yeah.
Do we have to write as a fraction?
What's half of 37? 18.5. I want it, if it comes out clean, like 18.5 or 2.75, that's fine. But this one would have been like, yeah. Okay. So, let's do an example. Did we all get to here? This was just practicing. This was just practicing cross multiply. All right, so let's do an example. Number 8. The ratio of what? Okay, so if we're going to put this into a ratio, we need to keep the same topic on top and the same topic on bottom. So this one's given to us in boys to girls. So boys to girls. So the ratio at this high school is 4 to 3. So we're setting up a proportion. So you're going to have something equals something. The first one is 4 to 3. So 4 over 3. There are 936 boys. So 936 goes on top because boys is on top. Over, I need to find what girls is, so x. Cross multiply, 4x is equal to 3 times 936, which I think is 2,808. Divide by 4. 702 what? What are we talking about? There are 702 girls. Alright, so right here is where we're getting into 7.7. We're almost done. 7.7. The rest of this was 7.1. This is 7.7. There's a thing called a scale factor.
Why are we skipping all the other ones?
Other what?
Why don't we go to 7.1 to 7.7?
Because they go, 7.7 is really small and it goes hand in hand with this. A scale factor is a unitless ratio in simplest form. So when we're talking about scale factors, we're usually talking about like an actual something to a model. Like this great example of the city project. Right? Look familiar? Okay. Is this a model or is this an actual city? This is a model. This is a model of a city. So when we're talking about a scale factor, you write the length of the model, which is this, the model on top, and however the actual city is on bottom. So model over actual. In number 9, the miniature replica of a 1923 checkered cab is 6.5 inches. That's the replica. Is that the real thing or a model? Model. Do you think a car is going to be 6.5 inches?
No.
No. So this is the model.
That's a model.
The actual length of the car was how long? Does that seem more realistic? Car is 13 feet long. This is the actual. So what's the scale factor? What did they use to get the actual car of 13 feet down to a replica of 6.5? We'll put the model on top, 6.5 inches over 13 feet. So their scale factor to make this miniature replica was 1 inch for every 2 feet.
How'd you know?
I just simplified this. Type in, divide this in your calculator. 6.5 divided by 13,
8.5.
which is 1/2. Leave it as a fraction. So their scale factor was for every 2 feet of this real car, they're going to make it into 1 inch of a replica.
Do we have a word?
Yeah, you can keep going. All right, let's do one more. A map scale is 1 inch for every 50 miles. Which one do you think is real? Do we count how far we're traveling in inches or in miles? Miles. So this is the inch over 50 miles, model over actual. The distance on the map between point A and point B is 3.5 inches. If inches is on top over here, inches also has to be on top over here. So I know that the map tells me for every 1 inch on the map, I'm really traveling 50 miles. Okay? So on this map, they are point A and point B are 3.5 inches apart. How far am I really traveling? So we get x is equal $175. So really, I'm traveling 175 miles. 3.5 times 50. Okay.